Now you may be pleased to know that we are about to cover our last data structure before moving on to some more exciting programming concepts such as control flow that make our programs come to life. But first things first, let's understand sets so we can use them in our programs when use cases crop up. So what is a set? Well, a set is simply an unordered collection of items where every set element, i.e. the item in a set, is unique. In other words, you'll never find a duplicate value in a set. Now, every element in a set must be immutable in nature. So as you know, this means it should contain things like strings and integers, for example, as these cannot be changed. However, a set itself, i.e. the data structure, is actually immutable, so we can perform more methods on them than we observed with tuples. For example, we can add or remove items to and from a set. Now, sets can also be used to perform mathematical set operations like union, intersection, and symmetric difference, all of which we will cover later in this section. Now, creating an empty set isn't the same as creating an empty list or an empty dictionary by simply placing a set of brackets, for example. So let's find out in the next video how we create sets as well as how we create an empty set. So as we've mentioned, sets are mutable. However, since they are unordered collection of items, indexing has no meaning. So with lists, seeing as they are sequenced, we can specify an index to bring back an item from the sequenced order. Sets, on the other hand, are unordered, so there is no concept of indexing. So with this in mind, we cannot access or change an element of a set by indexing or slicing. The set data type does not support it. So just to prove this, let's create a very simple set with the integers 1, 2, and 3. If we now try to access the first element in this set, i.e. the number 1, you would think we might be able to put my_set, open square brackets, and pass in index 0. But seeing as they are an unordered collection of items, and indexing therefore has no meaning, we get back a type error telling us that the set object is not subscriptable. In other words, we can't use indexing or slicing operations. So with that being said, how can we add an element to a set? Well, if we want to add a single element, we can do this using the add method. So if we put my_set and then utilize dot notation and place our add method afterwards, we can then put the element we want to add inside of the parentheses. So if we put the integer 4 and then take a look at what's stored inside my_set, you can see that 4 has been added to our set. Now the add method is a way of adding a single element, but if we wanted to add multiple elements, we're able to do this by utilizing the update method. Now the update method can take tuples, lists, strings, or other sets as its arguments. But in all cases, any duplicates you include inside of these data structures will be removed. So let's take a look at a couple of examples. If we now try to add the integers 5, 6, and 7 by passing them inside of a list inside of the update method's parentheses, you can see that 5, 6, and 7 have been added to our my_set variable. And it's the elements inside of the list that have been added, not the list itself, because we know that lists can't actually be included inside of a set, seeing as they are mutable objects. Now if we wanted to, we could pass inside of the update method's parentheses a list, so we could have 8 and 9, and then we could also pass in another set, so we could put 1, 4, and 10. Now if we print out my_set, all of the elements have been included accordingly, however, where there are duplicates, they have not been included. So you can see here 1 and 4 haven't been duplicated, but the number 10 has been included in our set. So to summarize, sets do not have a concept of indexing. To add a single element, we can use the add method, and to add multiple elements, we can use the update method. So let's now move on to some set operations. Sets can be used to carry out mathematical set operations like union, intersection, difference, and symmetric difference. Now we can do this by using operators, so a specific symbol, or we can utilize specific methods, which we will observe in a few examples. So let's suppose we have two simple sets of integers, and we'll store the first set in a variable called a, and we'll have this span from 1 to 5. And the second set we'll label b, and we'll have this set spanning from 4 to 8. So two sets with 5 integers each. Now upon observation, we can see that the integers 1, 2, and 3 only exist in set A. 6, 7, and 8 only exist in set B, and 4 and 5 exist in both sets A and B. Now if we were to depict this in Venn diagram form, it would look something like the following. Now the left-hand segment, which is labelled A, would relate to those items that are only included in A. The part on the right section labelled B would relate to those items only included in B. And the middle section would relate to those items that are shared in both A and B. So if we were to perform a union on both A and B, this would mean we bring back the items from each segment into a single set, i.e. the left segment, the right segment, and the piece in the middle. And the way we can perform this is firstly by utilising an operator, which is the pipe symbol, the symbol that is a vertical line. And we place this in between the variable names containing our sets. So we could put A pipe B, and when we run this code, we get a new set returned with the integers from 1 through to 8, with the duplicate values removed accordingly. So we only see the elements 4 and 5 written once. So very simple to perform. We can also get the same result by using the union method. And seeing as the result will always bring back each value from each segment, it doesn't matter what set we pass in as a variable into the parentheses. Let me show you what I mean. So if I start with the variable labelled a, which we know is a set object, and then place a dot, we can then put the union method, and inside the parentheses we can place the second set we want to union. So in this instance it would be variable b. When we run this code, we get back the result with integers from 1 to 8, just like we saw when using the pipe operator. And if I change this so we call the method on variable b and pass in a into the parentheses, we get the same result. So a union operation will combine two sets together and take all the values from both sets and bring back a new set without any duplicates. You can use an operator, which is the pipe symbol, or you can use the union method in which you pass a second set into the parentheses. The next set operation we're going to cover is known as set intersection. And set intersection can be visualized as follows. It brings back the middle area, i.e. the middle intersection where both sets cross over. And we can perform an intersection operation by using the AND operator, i.e. the ampersand symbol, and we can also achieve the same result by using the intersection method. So let's see a couple of examples. If we use the two sets created in the prior video, i.e. A containing integers 1 to 5 and B containing integers 4 to 8, if we type A ampersand B, you can see that we bring back 4 and 5, as these integers are shared in both sets A and B. Now, because the intersection relates to items that are shared, it doesn't matter how we call the intersection method. So if we call the intersection method on our A variable, and then inside parentheses pass in set B, we get the same result showing 4 and 5. If we were to call the intersection method on variable B and pass in set A into the parentheses, we also bring back 4 and 5. And we could then save this in a separate variable in order to use elsewhere in our code. So set intersection enables us to combine two sets and obtain the values that are shared in both. Now the final set operation we're going to observe is known as symmetric difference. And what symmetric difference allows us to see are those items that are included in either set A or B, but if they are shared, we will not show them in our result. And the way we can perform symmetric difference is by using the caret operator, i.e. the little arrow that points up. And the same can be accomplished using the symmetric underscore difference method. So let's see it in action. Seeing as we know that items 4 and 5 are shared between sets A and B, these would be the values we expect to be removed from our final result. So if we put A caret B, you can see we get a result set 1, 2, 3, which is from set A, and then 6, 7, and 8 from set B. 4 and 5, seeing as they are shared values, will not be included in our output. Now, because there is only one result set that can be obtained, it doesn't matter what we call the symmetric underscore difference method on, it will obtain the same result. So if we put A dot symmetric underscore difference and then pass in B to the parentheses, we get 1, 2, 3, 6, 7, and 8. And if we were to also call the symmetric underscore difference method on B and then pass in A into the parentheses, we once again get 1, 2, 3, 6, 7, and 8. So the symmetric difference operator allows us to obtain the values from both sets, but those values which are shared will not be included in our final result. Okay, so let's quickly take a look at some useful built-in functions that we can use with sets. So if we start with a set called A, which is a set of integers from 1 to 10 in a random order, we can first of all utilize the built-in len function, which we know brings a count of the number of elements contained within the data structure. So if we put len brackets A, we can see that we get back the result 10, which tells us there are 10 elements inside of this set. We can also utilize a built-in function called max, and what this will do is it will find the maximum value within the set. So if we pass in A into the built-in max function, we get 10 returned, but this time it refers to the number 10 as opposed to the count of items. If we use the opposite function, which is min, we can pass A into the parentheses, and this will bring back the value 1 because 1 is the smallest integer within this set. We can also use the built-in sorted method, which we've seen when working with lists, and what this will do is return a new list containing all of the items from the set in ascending order. But we can also turn this into descending order by passing in a second argument, as we've seen previously. So if we run sorted and then put A inside brackets, we get 1 through to 10 in ascending order. Now we can also use the built-in sum method, so if we pass in set A into the parentheses, we get the result 55 returned, which is simply the sum of 1 plus 2 plus 3 all the way through to 10. Now we can also, like we've seen with lists, tuples and dictionaries, perform membership tests. So if we want to check if the integer 1 is in the set that we've stored in variable A, we can put 1 in A, utilizing that in operator, and we can see we return the result true because 1 is indeed in the set stored in A. If we put 11 in A, you can see we obtain false as we only go up to 10. Now if we put 11 not in A, because 11 is not in A, it evaluates to true, hence we obtain a true result. So a few built-in functions here that we can use with sets that can come in very useful, and we could also perform membership testing like we've seen with other data structures.